In this video, I would like to show you how to construct a box and whiskers plot, box plot for short. And I'm going to use the data set that we're already familiar with. You saw it in the previous videos. That's a sample of student heights from my previous class. And okay, so in order to construct a box and whiskers plot, we need what is called a 5-number summary. Okay, so here it is. Here's the description of a list of what those 5 numbers are. Okay, so we're going to go through doing that step by step with this data set. Okay, so the first 2 numbers, I mean, they're not the first actually, they're actually the first and the last number. Okay, so your minimum value and your maximum value are going to be 2 values of your 5-number summary. So for the minimum value, we have 60. Then we're going to have 3 more numbers, and then followed by the last number, 73. So the minimum value and the maximum value go into your 5-number summary. Another value that goes into a 5-number summary is your median. Okay, so the median is going to be the number in the middle. So we, in the previous videos, we figured it out to be 67. Okay, so now let me describe what's happening. So our 67 was a number in between basically, oh, not the wrong place, sorry, it's here, in between the 14th and 15th, no, 7th and 8th, yes. Sorry, I was thinking that we have 14 data values in all. So this value was right here. 67, it was the average of these 2 values, right? So your median, it divides your data in 2 portions, basically, the lower half and the upper half. And we have exactly 50% of data values below the median and above the median, exactly 50. So the other 2 values that we're going to be looking for, these ones, are called quartile 1 and quartile 3. So the quartile 1 value, it actually divides the lower half in 2 equal parts, just like similar to how the median divides the whole data set into equal parts. Then quartile 3 will divide the upper half into equal parts. Okay, and the process of finding those values is actually the same as the process of finding the median. Just instead of looking at the whole data set, we are going to look just the first half separately and the last half separately. Okay, so let's do this, and I'm going to use my location formula. You could do the crossing out the values from both ends if you like. If you don't have a large data set, that's fine, but if you have a large one, then we're going to use the formula, and the formula is n plus 1 divided by 2, remember. But this time, we're going to look at this data set, and we have 1, 2, 3, 4, 5, 6, 7 values in there. So n is 7. And so location quartile 1, Q1 is abbreviation for quartile 1 value, and we're going to find a location, And the location for quartile 1 is going to be 7 plus 1 over 2. Remember the formula? It's n plus 1 over 2. So we have 8 and divide by 2, that's value number 4. Again, that's location. This is not the value itself. So we have to go into our data set and find that value. 1, 2, 3, 4. So this is our Q1 value. This is quartile 1 value. And as you can see, this value divides our set perfectly. We have 3 values below it and 3 values above it. Okay, the same thing is going to happen on the right side. Okay, so again, since we have equal value below the median and above the median, this data set should also have 7 values, which it does, and we don't have to. So for Q3 location, we do the same thing. It's going to be value number 4 in this string in the upper half. So counting 1, 2, 3, 4, here it is. So this is our Q3 value. Okay, so we're gonna finish constructing our five number summary. So 65 goes for Q1 and 68 goes for Q3. So we have 60, 65, 67, 68, 73. Minimum value Q1, median Q3, maximum. Okay, so I want to repeat just once more that the median divides the data set into 2 equal parts, 50% below, 50% above, and then each quartile value divides the quartile 1 value divides the lower half, and quartile 3 value divides the upper half. So below quartile 1, we can find 25% of values, right? And 75 above it. Now, for the median, we have 50 below, 50 above. For quartile 3, we have 75 below and 25 above. That's why, so basically we have 25, 25, 25, and 25. That's why they're called quartiles. And median could be called quartile 2 as well. And so what I want to point out now that those are also, we're going to be, in the future, we're going to be talking about percentile. We will be able to find the value that separates, for example, 10% or 30% or 45%. So it doesn't have to be like 25, 50, and 75. These are probably the most important ones, but we will be able to find other percentiles in the future. So Q1 is actually percentile 25, so meaning that it separates the bottom 25% of your data values from the rest. Okay, your median is percentile 50, so 50% below and 50% above, and your Q3 is percentile 75, so 75% of data below and 25% above, just like I mentioned before. So this is just a quick introduction to percentiles, what they are, and we're going to be talking about them in more detail later. But for now, let's use our 5-number summary to construct a box plot. And actually, I forgot to mention something before we move on to the plot, is in our case, this is our scenario. We had our median was actually a value that was not part of the data set. So it kind of divided the data set, but it did not take out any values from the actual data set. Our Q1s and Q1 and Q3 they were actual data values. I mean, here it is actual data value because there is no change from the left side to the right side, but it's not always going to be the case. Sometimes they will be different, then the average will be different as well. I hope you understand that. But it's kind of like divided without actually touching 67 on the left and 67 on the right. Now for Q1, it was actually that value number 4, and for Q3 it was this value number, now it's not 4, it's 11. Okay, so what do you do if even your median is the actual value from the data set? So let's say we didn't have 14 values, let's say we had 15 values. Then the formula would give us 15 plus 1 is 16, divided by 2 is 8. So our median would actually be this value, number 8. So what do you do then? How do you find the quartiles? So the rule is, here's an example. Here we have a 4-number data set, and the median is value number, it's value number 3. So, and this value divides into lower half and upper half. So when you find quartiles, you don't take this value into consideration. You're only looking at 10 and 11. And so the Q1 value would be the average of 10 and 11, which is 10.5. And for the upper half, similar, you're just looking at this data set, 19 and 20. Okay, so you take this out, this value out completely. Where in the case when your median is not a value from your data set, it kind of divides, but both 15 and 19 stay in 15 stays in the lower half and 19 stays in the upper half. So that's one thing that I wanted to add right now. And let's go and do our dot plot, box plot. Okay, so here I have my 5-number summary for my data. And what I need to do, I need a number line. I don't actually need the y-axis, just one. And by the way, I just want to mention right now that box plot is used for only one variable data. Just like our heights, there is only one variable, the heights. And let's label that. Heights. Student heights is what this variable represents. Okay, so what you do is you draw a line above each one of those numbers. So 60 and 73, minimum and maximum value. And then 65 is another one. 67. 68. Okay, so lines above each of those numbers. And then for the middle 3, you're gonna make a box with them like this. Okay, so with this, okay, we're gonna talk about what that means later. And then for the rest, for the other 2, you're connecting them with whiskers. So this is why this graph is called a box and whiskers plot. So what this gives you, it says that 50% of your data is located right here between the values 65 and 68. This is the middle 50%, okay? So, and the rest We have also 25% here, 25% here, and so this shows you the spread of your data. All right, so let me know in the comments if you have any questions, and I'll see you in the next video. Okay, before I let you go, I just wanted to mention that what you need to be able to draw from this graph. Of course, you see the minimum and the maximum value of the data set. You don't have the original data set, of course, the original values, but you can find the minimum and the maximum. You could also see where the median is. And you could see if the data is skewed or not, but we're going to be talking about that later.